Morning, ladies and germs. I was talking to Steve Robb yesterday, and let's see, we got the circuit going here, and as you can, I don't know if you can see this. It says, oh, we're pulling 10 milliamps here. Here's the problem. I thought his project was pulling 300 milliamps, and I said, well, I could certainly get better than that. And so I got it down to 10 milliamps. Now this op amp, I'm using the 358. This op amp without a load pulls 0.8 milliamps. That's just under 1 milliamp, which is fine, but that's without a load. But once you add resistances that have to measure constantly, that current goes up. So what we can do is we could try playing with the values, maybe increasing the resistances up a little bit by an order of magnitude. We could try that. But I don't think that this op amp is going to be a good fit for this project, and we're going to have to go with something smaller. This project is not going to be able to be built on a breadboard. It's going to be very difficult for the home enthusiast to do it unless they have a reflow oven, because the parts that we're going to be using are called DFNs. Those they're really small. They don't have leads. They just sit flush with the board, and they're soldered from underneath. So you can't use a soldering iron to do this. It just can't be done. You have to have a reflow oven in order to reliably have it mounted to the board properly. So this project's already become more and more complex. I have a number of those types of op amps in my personal stock, and let's see, it's going to take a while to I don't know, just to research alone, to find out what the pitfalls and the variables are going to be to accomplish this problem, and to get the current flow, the current usage as low as possible. I was also thinking having this not run off of the system itself and having its own power supply with its own solar power. But that's the problem, and yeah, and just have it do it like that. Maybe have a 9-volt battery as a backup with a super cap on there, and there's a couple really good companies. Entersil has a bunch of good energy harvesting components that can that handle this kind of situation all the time. So maybe we can play around with looking at those. So this video is pretty much just an update on where we are right now. Just to show you what I do have working here. You can see that. And if I shut this light off, we go on. So depending on how much light falls on the sensor determines whether or not this transistor is activated, and it allows current to flow. So here's the whole circuit here. This potentiometer here determines whether or not it sets the sensitivity. Okay, so you can set it up so that you really have to get right on top of the sensor in order to make it work. Okay, so we can adjust that back. See this? Okay, so that's where we are now. The problem is this circuit pulls too much current. So we got Sue Pyro here. He's been looking over the circuit really well, and you know, he's not happy with it. That's not good. Mr. Moo Moo's here too. So there you go. This circuit's out. We're going to pick something different to play with. So there's an update for the electric eye, and we're going to have to scrap this idea. We're going to have to go with another plan of attack. Okay, so that's that. Good night, ladies and germs.